Yeah, so good to see you all. Yeah, first time here, so it's a huge honor for us coming here. Like, in our university, our exams are going on. We skipped it to be here, so I hope no one sees us on YouTube or something. Yeah.
Yeah. Yep. Hey, everyone. The talk we have for you here today is the byproduct of a lot of discussions we've had over at Prometheus-Operator about we recently started implementing the DaemonSet model for the Prometheus agent, and this is the byproduct of those discussions. So, just a quick introduction. I am Viswanath Sai Muthu. You can call me Vishwa. I am a contributor and GSOC mentee at Prometheus-Operator. I worked on extending this CRD called script config. We're hoping to promote it to beta and stable soon. And I'm a final year engineering undergrad at the Indian Institute of Technology, Varanasi. My hobbies are I love to play football, badminton, cricket. I play a lot of sports, and I love dogs. Yeah.
Yeah, I'm Shriram Ashwin. You can call me Ashwin. So yeah, I also worked like him as a GSOC mentee at Prometheus-Operator. I worked mainly on documentation website, and now after completing my GSOC project, I'm now the maintainer in that website repo. I'm also a final year student at IIT BHU, like him, and yeah, my hobbies, I like singing, even listening to music, and love doing sports. We both play football together.
Yeah. Just a quick show of hands.
Yeah, so how many of you use Prometheus Agent? Right.
That's
yeah,
great.
Nice.
Oh.
And how many of you use Prometheus-Operator? Yeah.
Okay, that's nice. That's a lot of people.
Yeah, so this talk is more of kind of a story that we wove around. It's an imaginary story. So let's get into it. So we will talk about a farmer named Eva. She's a very futuristic kind of thinking. So yeah, she uses tools like IoT devices, bots to monitor a field. She collects data using monitoring tools like Prometheus. So yeah, she likes to do stuff, analyze the data to a lab. That is her main priority, to improve.
Yeah. We totally did not rip this off from Arthur and Nicholas. So Eva has 2 farms, and to make it easier for us, we call each farms a cluster, and each acre of land in the farm will be called a node, and each individual IoT device will be a pod, from where we can collect metrics using her Prometheus server with a HA pair, each of her clusters, right? So that's what she does. She collects metrics from farms and sends it over the wire to a lab to analyze and improve her productivity.
I mean, but every time there are some downsides, and when she look at her expenses, the monthly bills that arrive, she's just shocked. I mean, she's spending a lot than she has expected, and she's confused about whether the setup is right for her. So yeah, she wants some alternatives.
And then she approaches us. Hey, that's us. So she approaches us for some ideas to help her gain more confidence in her Prometheus setup, and yeah, look at us, happy, like a little family. That's so nice. To understand her needs better, we're going to have to ask her some questions and hopefully give her good, solid advice.
We can look at the questions, like basic stuff, like the functionalities that Prometheus offers, alerting, use of local storage, TSDB, and all. So as you can see from the responses, there's no use for querying that much, so local storage doesn't also get utilized. So the main requirement she has, she wants to send her data to labs for analysis. And looking at that, we consider that Prometheus agent would be more suitable compared to Prometheus server.
Yeah, but before we can double down on that, she's having doubts, like what is the agent, what is the server? So let's just give her a quick brush up on these 2 things. We all know the server, we've all used it. You get the whole package. It can find and scrape targets for you. It has its own local TSDB. You can query data from there. And well, you can do alerting locally as well. However, not everyone needs all of these things. And in the case of Eva, she doesn't really seem to be querying any local data at all. I don't think she can even make sense of that. She sends it over to the lab for her experts to handle it.
Yeah.
That's where.
So there comes Prometheus Agent. So yeah, you have cut down the package, all functionalities from the package, and you just focus on like service discovery, scraping. But the implementation, the binary is same. So yeah, you get all the things that Eva need for a setup, but it can be a little lightweight compared to the server.
Yeah. You can also do alerting, but just at a different spot at the monitoring pipeline. You can do alerting at where you store your data.
So yeah, hearing that,
Eva was delighted, and she says, thank you. But that's not it. Hey, wait up, Eva. There's more to it. Give us more details about your both farms. Maybe we can help to assist you better.
Yeah, so let's just counter one farm at a time. So the first farm, we look at the crops are magical. Magical in the sense like they can grow very quickly in minutes. So she has a lot of large cluster or large farm where the demand is very fluctuating. Fluctuating in the sense that sometimes in the morning you have 5 acres of land, but then demand changes, and in the evening you need 10 acres of land. So yeah, and depending on the piece of land, she has different data like parameters like soil moisture, temperature. So she needs node-specific metrics. And then the main priority is to send her data to the lab, so she might use remote write.
Yeah, so it looks like in a day, in a cluster, in the morning, she might only need 5 nodes, but then in the afternoon, it might spike up to 10 or 15. You don't know. So it looks like she might need some automatic scalability here. So enter the DaemonSet mode for the agent. In one word, it is tightly coupled to nodes. That is, whatever node that your agent resides in, it is designed only to collect data from metrics from the pods on that same node. So that we can call that node local scraping. And you can, out of the box, also collect node metrics. You don't really need a node exporter here. And then if you have a new node in your farm, like with Eva, if in the evening it is 10, then it automatically scales. The number of agents also scale along with the number of nodes. So that's pretty neat. We have the current opinion that the DaemonSet might be pretty suitable for this cluster, but we need to ask her a few more questions before we can be sure of that. First thing is, does she need multi-tenancy? So let's just take a small look at multi-tenancy in the DaemonSet mode. You can do a couple of things here. You can either deploy n DaemonSets for n teams, but that is that's too much. That's not really an ideal solution. You can have one daemon running per node, and then have it collect all the metrics, and then have the multi-tenancy happening at the storage level, at the Thanos, or wherever you're storing your data. One other thing that you can do is have one daemon, but with different jobs, send the metrics for each team to a different remote write endpoint. That is also possible, but that's asking too much. Some teams might not even have their own endpoints. So it really depends. The two options are there. And also, the remote write CRD is actually in talks at the Prometheus-Operator, if you want to take a look at it. The DaemonSet mode is suitable, but it really depends.
Yeah, so after the quick explanation, we get to Eva's response. So she doesn't consider multi-tenancy for her case. So yeah, that's great for us.
Yeah. And then what about metric loss? What about reliability with the DaemonSet? So as I said earlier, the DaemonSet is really node-wide, if you can really think about it like that. So if one agent goes down, that means you lose visibility on that node completely. However, this might not be of a big concern for a lot of people. So that really depends. You can also have 2 DaemonSets running, but in our honest opinion, that seems a little too overkill for this. Yeah, there are countermeasures against this, though. We'll take a look at it later on.
Can I add something?
Yeah.
Yeah. So the visibility, like the loss of metrics, is for like very little short of time, like 4 or 5 seconds. So I mean, it might concern some people who want like 0 or very less loss, but like for her case or like normal people don't concern that much with it.
So the conclusion is DaemonSet is reliable, but it's not as reliable as a HA pair that you would have with your normal server. It is more resource friendly than a HA though, because you're only having, pretty much half. And then automatic scalability is also there, but the reliability is lesser.
Yeah, so getting back to a response, yeah, she could live with few loss of metrics, I guess. It's not like she needs high availability pair for everything.
That's very convenient. Okay. This question is really specific, but I think it'll make sense in just a second here. Would you be comfortable adding an extra layer of complexity to your cluster? Well, I say that because the thing with DaemonSet is that you define a DaemonSet, and the resource limits for all the daemons is the same. But the problem is, different nodes might have more number of pods, or some node might have pods that emit more metrics than some other nodes. So it is really possible that some of your agents are really short on resources. So you have to make extra sure that you have the resources available. Otherwise, you have the problem of your nodes, your agents getting killed and losing visibility on your really busy nodes. You can battle this, though, with trial and error tuning. You can have a meta-monitoring setup to see what really works for you, what is the ideal resource limits that you would need. If you want to go a step further, you could also use VPAs and just ensure that the agents don't die. And then you could also, you should also, in our opinion, go for high priorities for the agents, because in some cases, if the agent gets evicted and is not able to be scheduled onto the node again, you might lose visibility for that for I don't know how long. So it'd be really nice if you have a high port priority there. And it's like we wrote this. She's okay. She does not concern with this, and so that's okay with us as well.
So yeah, let's look at another question. So yeah, scraping resources other than pods like service, endpoints, and all. So currently, we don't have any support for that. But yeah, technically, it is possible to scrape any kind of resource. So maybe we can, in future, expect something like that.
Yeah, though it is possible technically to scrape other resources as well, maybe say a service, an endpoint slice or something like that. You can't really do that as of now with GMP or the operator. But at the operator, we still have the option open. We might be doing it in the future, just not now. So this is kind of what you have. This is what you might ask yourself before you want to see whether the DaemonSet is a good fit for you or not. And this is like really scripted, and so everything is perfect for the DaemonSet, and that is the winner. For the optimal solution for the first scenario would be the DaemonSet mode. She has a large cluster, and she needs dynamic scaling, so that works perfectly for us. And she can possibly reduce some resource consumption as compared to what she would have had with the HA server. And you have native support for the node metrics as well. That might not be super important, but it's definitely something nice to have.
But yeah, before moving to the second farm, we need to give a shout out to Hanwu, a GSOC mentee with us, who is working in the DaemonSet mode in Prometheus-Operator. She is currently in the final stages of it, and maybe in the next few releases, you will see and you can utilize DaemonSet mode.
In the Prometheus-Operator.
Yes. So if we look at some considerations regarding the DaemonSet mode, like we already discussed, like scheduling, priority, and busy nodes, I mean, you need to ensure it. And dynamic vertical scaling, you can add VPA, but like it's more of a complexity to a setup, so it's a trade-off, whether you want more complexity or you need like more thorough understanding of setup. Then multi-tenant meta-monitoring, that is something like if you want visibility about what node, where is the daemon going down, you need more data. So yeah, you can do that. And multi-tenancy, like we have a bunch of methods.
Yeah, the point is that it's not as simple as with your normal server where you just assign a team a namespace. With the DaemonSet, it's really not so simple if you're only having one DaemonSet per node and one daemon per node, and it cannot really scrape some of the pods which are not in the same namespace. So yeah.
Yeah, so one down, let's get to the second one.
Really quickly.
So yeah, compared to the first one, this is like 180 degrees. So this one is pretty much stable farm. This is a main source of income. So Like she wants very reliable setup. This is a large farm, large cluster, predictable demand. Like the crops are not that magical, I guess, compared to last time.
Yeah.
But yeah, and the final thing to send her data to the lab. So she needs remote write again.
Oh yeah, this is very similar to what you have with your server. It's just that it's an agent, and you don't really have any local storage. You directly send to a long-term remote storage. And that's it. As far as the reach goes, it's cluster-wide. You can pretty much scrape anything in the cluster out of the box. There's no restrictions on that as yet.
Yeah, so again, we'll come back to the questions because we need more further analysis for this farm. So yeah, first question was like, again, managing multiple teams in your cluster. So yeah, in this case, she wants because like this is the main source of income. So you can do that easily in StatefulSet mode because that's just pretty simple like server. You can assign one team one namespace. You can fire up an instance of agent and you can work it out easily. Then.
Yeah, and same with the reliability here. If the reliability is a really big problem here, and I think high availability with your stateful set is going to be really good for her to avoid loss of metrics as much as possible because you are literally scraping the metrics twice.
Yeah.
So, yeah.
Yeah, then again, similar to DaemonSet, like, do you want to scrape from other resources? DaemonSet might not be suitable for that, but like StatefulSet is the best choice.
Yeah.
Yeah, you can easily, like we talked about out-of-the-box scraping, we can do it for service, ingress, and all, any kind of resource. So, yeah. So
yay!
Yeah. Okay.
So yeah, you can use the StatefulSet mode for this.
Yeah, so I mean, StatefulSet mode shines for this case, like because ensuring reliability is easier compared to DaemonSet mode. Set up a high availability pair. Then multi-tenancy also, you can use namespaces, or you can even do labels and scrape anything, yeah, any
Scrape
kind of
away, man.
resource.
Yeah. The considerations you would have here are horizontal scaling because it's not really possible to automatically scale. It is possible, but it's not as seamless as it is with the DaemonSet. So that is something that you have to consider. And then node metrics. You are going to have node exporters running on your nodes to really get any node metrics using the stateful set.
Yeah.
So in summary, both of these are really nice modes to have, and they both have different models where they fit really well. And for the DaemonSet mode, it's usually when you have a very dynamic cluster and you really can take advantage of the automatic scaling capabilities that it offers. And also the failure surface is reduced here. It's only, you lose visibility only on one node, and maybe not for too long. It shouldn't take too long for your daemon to restart, to be honest. It should be pretty low of a time. Depends on what you consider. And then it might not be as reliable, though that is definitely an issue. And multi-tenancy might get a little complicated for you as well. So it's really nice if you can have meta-monitoring running for your DaemonSet mode to try to be on the front foot with reliability.
Yeah, coming to StatefulSet, like you can imagine like the inverse scenario for DaemonSet. Yeah, you can ensure cluster-wide scraping, more reliable, set up easily, like a high availability pair. So straightforward, similar, but you can't get automatic scaling out of it like DaemonSet. It can be done, but it's pretty complicated. I don't see a point of doing that, I guess. So even the resource consumption with the high availability pair might be a problem for some people. So it's like a trade-off between both the models. So you need to make your choices depending on your setup.
Yeah. Thank you. That's it. And we really like to thank our mentors, Arthur, Nicholas, Simon, and Jayapriya. Arthur and Nicholas have really been babysitting us here. Thank you really for that. And yeah, we can move on to Q&As if you have any questions.
And you can get this side.
Questions? Yeah. It might sound stupid, but did you play with pod level deployments as well, like sidecars?
Oh, no, not really. We didn't go for sidecars, no. But I don't see why you would want to do that. Can you give me a use case?
Yeah, I mean, I come from a tracing background, right?
Okay.
So there it makes some sense to have sidecars instead of DaemonSets or stateful sets.
Right.
But for metrics, I'm not quite sure it makes sense. And I would want to hear, from you if you've played with that, why wouldn't it make sense?
Okay, that's not actually something we've considered. Maybe we should look into that later on.
I can answer that for you. I have a proposal in the Prometheus-Operator project proposing a sidecar, and it was widely refused because Prometheus has... The idea with a sidecar is that you have a very, very small pod, and that doesn't really change the overall size of the pod. It needs to be very small. And Prometheus has some limitations. There's, for example, the wall has a very specific size. There is a few megabytes, and a few megabytes is, for the people reviewing at least, is already big enough to not consider as a sidecar.
So now that you have the mic, Arthur, you need to help.
You said that DaemonSet mode for Prometheus Agent has less reliability than StatefulSet mode, and I don't understand why. From my perspective, DaemonSet mode should have bigger reliability because the agent runs inside the node, and if, as you said in your talk, the point of failure is usually the whole node.
Yeah.
If node disappears, then you cannot scrape it outside and inside, and there is no difference between the level of reliability. On the other side, sorry, that's not a question, it's just a discussion. On the other side, when you scrape node from outside, this means that you rely on networking between nodes, and this another point of failure. And this point of failure doesn't exist when you scrape local pods inside node. That's my comment. You can also add some.
I'm not sure, but so you were saying that if you're scraping out of the node-to-node communication is also a problem. Was that the question? Okay. I don't know. Does it matter to Kubernetes that it's outside the node? I don't think the networking in Kubernetes, I don't think it really, does it make sense for, are nodes entities in the Kubernetes networking cycle? I don't think so. So maybe it is a problem, maybe it's not.
I guess it doesn't matter for Kubernetes, but like the Prometheus running just sees whatever is on the node, right? I think that's kind of what he was saying. But yeah, it was a statement, but I think we've been pretty good with statements versus questions ratio-wise. Any other questions? All right.
In the stateful set, so I haven't seen that you can do sharding because it can be pretty beefy. Can you?
Sorry, I don't get it. What?
In a stateful set, because in a daemon set, you're basically doing one pod, which should be big enough to scrape everything. In a stateful set, you're doing two probably nodes, which scraping everything, each of them. Right? But
yeah.
Can you do sharding as well per node?
Is the question, can we do sharding?
Yeah.
Yeah, we can do sharding, yeah, for sure.
So it's supported inside of CRD somewhere. How do you work with it?
Sorry, is it?
How do you configure it? Is it like additional CRD in Kubernetes or what?
Oh yeah, you can use hashmod relabeling for that.
Oh.
Yeah.
You can add labels to the, you can do, let me think, let me think a little bit. You can definitely do that, but you can do with label selectors and add labels to the nodes.
Yeah.
Prometheus-Operator, Nicholas probably has a better answer.
Yeah, I mean, like for the agent mode, like there is only no way to have sharding because this means that you need to have another pod running on the node. Okay, so by default we don't have sharding for that. You might deploy another Prometheus CRD and deploy yet another like pod running as a demo set, but like it's a workaround.
So basically, sharding is for like running a stateful set and then sharding all the targets across multiple replicas, whereas like DaemonSet, you usually scrape everything on one node. And
yeah, because you're already doing
how
sharding.
are we on time? Okay, we can discuss sharding a bit longer.
Yeah.
At this time, I have a question regarding when this agent runs in DaemonSet. How does it perform discovery of pods to scrape in this node?
Right.
Does it communicate with API server or not?
You want to take this? So there's this thing called field selectors, and you basically pass down the name of the node from the config reloader, if I'm not wrong. So from the config reloader, you get the name of the node that the daemon is running on, and then you pass it to the field selector within the within the agent. So at discovery time, you kind of filter only the pods that are present in the same node. Does that make sense?
Yeah.
So from what you said, this means that every agent in DaemonSet at every node needs to query API server, Kubernetes API server for this information for pods which it needs to scrape, and this means that this doesn't scale well with the number of nodes in Kubernetes. More nodes you have, higher load on the API server you have for service discovery.
I think filtering at the time of service discovery should not give you as much of a load on the API server, to be honest. I think that's why we do field selectors as opposed to something else like label selectors.
Did you think about some solution which doesn't require querying this API server, probably querying local C advisor or something like that for pods which will run locally and scrape metrics from them?
To be honest, I'm not the one who who came up with the idea of the DaemonSet, but I think they did go through other ideas, and the most efficient one was this. Yeah.
I'm not sure if Kubernetes has a watch strategy instead of fetching. If there is a watch, maybe that's a better idea.
Additionally, I think you want to go through the API server because you need all the metadata labels that come from the API server for like pod name and namespace, whatever. Like just going through C advisor, you might not have it. I don't know exactly, but I think Kubernetes has proven quite a significant scale. So if you run into that problem, then talk to the Kubernetes maintainers. Good job getting there.
Do we have time for more?
We have time for one more.
Okay.
Hi, Mershat from Deutsche Börse Popular Service Bank. Really nice talk. I really enjoyed it. From the technical aspect, it looks really good. From the business side, is EVA a real EVA? Is it like business asking you to use Prometheus for this purpose?
I'm sorry, I don't think I get your question.
So is EVA a real EVA, like meaning you work Prometheus for farming business?
No. It's like we ripped the story off of Arthur and Nicholas. You should really ask them, to be honest.
Permission granted.
Yeah.
Just a side hustle.
Yeah.
All right. Again, big round of applause for the amazing talk.